So for this problem, like I had it written down, I would, for this calculator, I would, just to be careful, I'd put this first thing right here in parentheses. And the way this calculator works, I do 6, and then I do choose the NCR, and then I type in 0. I'm going to close the parentheses, and then I'm going to say times, and then I'm going to say 0.68 raised to the 0 power, and then I'm going to say times 0.32 raised to the 6th power. And I'm going to press enter, and it gives me 0.001. I mean, it's a lot more decimals, but I round off to 3 decimal places, because 2 decimal places I would have to write down 0, but this would be 0.001. And then to calculate 1, I'm not going to calculate all of them, but I'll calculate the next one just so you can see the pattern. So if I'm going to calculate the probability of exactly 1 yes from the 6 people, then I would do 6C1 0.68 raised to the 1 times 0.32 raised to the 5. Now remember, whatever this number is right here, that's what goes right there, and then this minus this one goes right there. So all I'm doing is following this formula right here. Now this right here is doing that NCX by hand. This part right here is if you do the NCX by hand. If you don't have a calculator that has this option, then you would do 6 factorial over 6 minus 0 factorial times 0 factorial. And by the way, 0 factorial is not 0. 0 factorial is 1. So, and then you would multiply it times p raised to the x times q. So it's just a pattern based on, you know, what you're finding the probability of. And this time I will go to the Desmos calculator and show you how I would type that in. So I went to, I did Desmos Scientific. That's what I picked. And the first thing I would need to do is go to function and get this formula right here. And then I would type in 6, 1, because that's how it works on this one. And then we're going to do times, and then we're going to do 0.68, and we're going to raise it to, that button right there raises it to the 1st power, and then arrow over times 0.32 raised to the 5th power. And then that answer is 0.01369. So I did 3 decimal places a while ago. So 1, 2, 3. So I'm going to write down 0.014. So as I run over here, I'm going to write down right up here 0.014. Now I'm gonna do you one more. I'm gonna say, so this one would be 6C2 0.68 to the 2nd power times 0.32 to the 4th power. And then you would just type that in and you would get the number. Now I'm going to go show you how to do it on StatCrunch, because StatCrunch you don't have to type all that in. So let's go over here to StatCrunch. And you don't even have to have anything in here. All you have to do is go to calculator, and you go over here to binomial. So hover over the stat button, go down to calculators, which is the first option, and then choose binomial. And when you do that, this thing right here pops up. It's already got a binomial distribution calculated, but it has one calculated for n trials, and the probability for success is 0.5. So we just have to go in here and alter our information. So for our problem, we asked 6 adults the question, and the probability of success was 0.68. And then what we are asking it to do is find out exactly, we ask it to find out exactly how many for 0. And remember, for 0, and it's showing you 0 right here, is 0.001. That's exactly what we calculated. So now you just go and you type in 1, and that was 0.01369. Remember, we calculated, we rounded that to be 0.014. So just type in 2, and so understand that what I'm doing now is I'm able to fill this in, because this part right here is whatever it says on StatCrunch, 0.0727. So if I do 3 decimal places, this right here, 1, 2, 3, this is 3 decimal places, so look at the 7. The 7 is going to round that 2 into a 3, so 0.073. And that's what I just wrote down right there. And then you just keep going on StatCrunch. You do what is 3, and 3 decimal places would be 0.206, and 4 decimal, in the 4 people said yes, they use Facebook. That is 0.328. 0.328. I did not make my table big enough. I'm really having to squish my numbers in right here. And then for 5 people said yes, they use Facebook. That's 0.279. And then 6 people said they use Facebook. That's 0.099. And if you had to say, if you had to describe if this data set was skewed, I hope you would say it's skewed to the left, because the tail is longer on the left side than it is. Notice that I was on standard. If you pick between, there could be questions that you'll answer about between, but not right now. You want it to fill in your binomial distribution chart. To fill that in, you'll want it on standard. Depending on what questions that we have to answer about these problems will determine whether you need to switch it over to between. But if your goal is to simply fill out this binomial distribution chart right here, then you want it to be sure to be on standard. Okay, so let's run back up here. Why do I keep losing my clock? It happens when I change. I lost my clock. That's okay. I don't know how long I've been talking. So back to this problem right here. Rotator cuff surgery has a 90% chance of success. That's your value of P. P is 90%. My sister's about to have this. 90% chance of success. If it's 90% chance of success, then what's its failure rate? 1 minus 0.9 is 0.1. The surgery is performed on 3 patients. So that is our N. That's our fixed number of trials. 3 patients, that's your fixed number of trials. Find the probability of the surgery being successful on exactly 2 patients. They're asking you to find the probability that X is equal to 2. So basically, if you wanted to fill out the whole chart, it's pretty short, because our X values here are 0, 1, 2, 3. So if you wanted to do a chart here and find them all, you could go 0, 1. I made this one a little bit bigger so my numbers would fit. And they're just simply wanting to know what goes right here. That's exactly 2. They could change and say 2 or more, or they could say less than 2, and that's when you have to figure out what they're talking about. You have to pay attention to the words, but this one's just asking you for what goes in this box right here. So you could use the formula, and the formula right here would be 3 choose 2 0.9 raised to the 2 times 0.1 raised to the 1. That's the formula that will find that number that goes right there. Or you can run over to StatCrunch and you can change the number of trials to 3, change the number of success to be 0.9, and then find the probability that X is exactly 2. And that answer is 0.243. So I would write my answer like this. The probability that X is exactly 2 is 0.243, or if you were filling in a table, that would be 0.243. And by the way, what do you know about the sum of the values of this table? I believe these should still add up to be 1. Because a binomial distribution, I think, is still going to add up to be 1. I really should have been 100% before I said that, but because I was thinking about, but that was when we were doing discrete random variables. They had to add up to be 1. So maybe this one doesn't. I don't know. But that's what that asked for. Now, this one, let's do this next one right here, and then I'll end this video. I don't know how long it is. A card is selected from a standard deck and replaced. This is a must. If it isn't replaced, then it's not binomial. Must be replaced to be binomial. This experiment is repeated a total of 5 times. There's your fixed number of trials. N is 5. Find the probability of, so success is a club. So you're either going to get a club or you're not going to get a club. That's success, failure. And they didn't give it to us this time. We're going to have to calculate it. So since we're replacing it, the probability of getting a club, is going to be, how many clubs are there? 13 clubs out of a total of 52. And since I'm replacing it, the probability of getting a club is going to be, that reduces down to 1/4, so that's 0.25. So we have a success rate of 0.25, you have a failure rate of 0.75, and since we had 5 trials, then my X value can be 0, 1, 2, 3, 4, or 5. Now it says find the probability of selecting exactly 3 clubs. So they're asking for this, exactly 3 clubs. And if we pick exactly 3 clubs, then you've got 2 choices. You can use the formula. The formula for picking exactly 3 clubs is going to be 5 choose 3 times 0.25 raised to the 3 times 0.75 raised to the 2. I just did 5 minus 3. So this right here, typed into a calculator, will find the answer that you can also find by going here and saying, I had 5 trials, my success rate is 0.25, and I want to find the probability of exactly 3. And I hit compute, and my answer is 0.088. 0.088. And you can see the outcome for all of the trials right there. So you can see that this one is definitely skewed to the right because the tail is longer on the right. I'm going to go ahead and stop the video before I work the last set of problems. because I don't know how long I've been talking because I lost my clock.